Chapter 6 Review Questions. Starting off with explain why sine of x is equal to 1/2. We'll explain why that has more than one solution. Using the unit circle, we can see that there are two spots on the unit circle that have a sine value of 1/2. They are here and here. So this height is 1/2. This height is 1/2. And since we can continue around the unit circle an infinite number of times, we'll have an infinite number of solutions. Using a graph to justify the answer, we can do a quick sketch of a sine curve. Sine starts at 0, 0, goes up to 1, down to -1, and back to 1, and it's cyclical, so that graph repeats. And if we sketch a line at 1/2, we can see that there will be an infinite number of solutions at 1/2. And part C, what does what does the inverse sine of 1/2 equal? Well, sorry, I'm moving my microphone. The inverse sine of 1/2 is only equal to pi over 6. There's only one output because only this portion on the unit circle exists. If you recall when we were drawing the inverse graph, if I do a sketch of the inverse of this graph, we have to restrict the domain so that it's still a function, and we only have values on this part of the graph. Moving on to the next problem. Solve each of the following on the domain 0 to pi. So for the first one, we want to solve for cosine of x. 1 moves over, it's -1 divided by 2. So we take a look at the unit circle. -1/2 cosine occurs here and here. So if we can't remember what is there and there, we can go around and count them. 1 6 pi, 2 6 pi, 3 6 pi, 4 6 pi, 4 6 5 6 6 6 7 6 8 6. We can write the two solutions in reduced form. 2 pi over 6 and 4 pi over 3 reduced. Okay, for B, we can square root the sine, so we end up with sine of x is equal to the square root of 3 over 2. On our unit circle, sine equals square root of 3 over 2 occurs here and here. 1 6 2 6 3 6 4 6. Reduced format, pi over 3 and 2 pi over 3. Part C, where is the tangent of x equal to -1? So back to the unit circle. The tangent is positive in this quadrant and this quadrant, and the tangent is negative in quadrant 2 and 4. So I'm looking here and here. So I'm looking for -1. Tangent is 1 at these two places, because that's when we've got 2 pi over 2, 2 pi over 2, and the tangent opposite over adjacent creates a 1, -1 and a +1. Same with here. So if we count that out, we've got 1/4, 2/4, 3/4. So 3/4 pi, 4/4, 5/4, 6/4, 7/4. So we've got x at 3 pi over 4 and 7 pi over 4. On to the next problem. Find a function in terms of sine and another in terms of cosine that will generate the graphs below. Alright, so if we want this graph to be sine, our beginning point needs to be right here. And our amplitude from 2 to 4, our amplitude is 2. And our period is pi. 1 complete cycle from here to here. And we can use our little equation. P times B equals 2 pi. So B pi is equal to 2 pi. So our B, our angular frequency, is 2. And then we need a H, a shift, and a K, another shift up. So we're right here at 0 for the horizontal shift. For the vertical shift, we're shifting up 2. So our equation in terms of sine would be y is equal to 2 sine of 2x plus 2. Now in terms of cosine. Most of the stuff stays the same. We keep our 2 cosine. Again, 2 times x. We just need to change our shift. For cosine, we start here. So we've shifted our starting point by 1/4 of a pi. So pi over 4 is our horizontal shift. And it's still moved up 2. Okay, for B.